Novdec 2025 Core Mathematics Paper 2, Question 9a. A sector of a circle of radius 21 centimeters subtends an angle of 120 degrees at the center. Let's represent this on a diagram. So we have our circle, and in this circle we have a sector that subtends an angle of 120 degrees at the center. Then this sector has a radius of 21 centimeters. So this is the radius, 21 centimeters. Now, if the sector is cut and folded to form a cone, so this particular sector here is cut out of the circle to form a cone. So let's draw our cone. This is our cone. Then we have to find to one decimal place the radius of the base. So one thing is for sure, once this particular sector is folded into a cone, the radius of the sector becomes the slant height of the cone. Take note, the radius of the sector becomes the slant height of the cone. I'm representing the slant height as L. So that is 21 centimeters. And then this is our circular base of the cone. So the distance from the circumference of this particular circle to the center of the circle is the radius. So this is the radius, and this is our perpendicular height. So from the apex of the cone to the center of the circular base, that is the perpendicular height of the cone, and this is the radius of the circular base. So now this is 9a. Now 9ai, we are to find the radius of the circular base, this r. So to find the radius, there is something that we should take note of. That is, we know that this is the length of the sector. In other words, the length of the arc of the sector. Once we fold this into a cone, this length here becomes the circumference of the circular base. The length of this arc becomes the circumference of the circular base. So there is a relationship between the two. Now we know that the circumference of the circular base is giving us 2 pi r, and this circumference here is the same as the length of the arc of the sector. And we know that the formula for calculating the length of an arc of a sector is given as theta over 360 times 2 pi r. So the radius of a sector is given as capital R. So that is why we wrote the R. The reason why we have capital R and the small r is to differentiate between the two radius. Now, since we are looking for the radius, what do? We divide each side by 2 pi. So the whole of this side by 2 pi. So what is left? So this 2 pi will cancel out, leaving r on the left. And then this 2 pi, and then this 2 pi will also cancel out. So we have theta over 360 times r. So let's take note of this formula. So to calculate for the radius of the circular cone, the radius of the circular cone is equal to theta divided by 360 times the radius of the sector. So we just do our substitution. We know that theta is 120 degrees. So this is our theta and this is our r. So we just do our substitution. So theta, we have 120 degrees divided by 360 degrees multiplied by the radius of the sector, which is 21 centimeters. So the radius, we have 120 divided by 360 times 21. So we have 7. And remember, we were asked to correct our answer to 1 decimal place. So 1 decimal place, the radius will be 7.0 centimeters. That is 1 decimal place. So that is for the I. Next, II. So II. We are also to calculate for the perpendicular height of the cone. I'm representing the perpendicular height of the cone as h. So this is the perpendicular height from the apex to the center of the circular base. Now consider we have a right angle triangle. So the perpendicular height and the base radius will always meet at right angle. So we have a right angle triangle. And we know the length of the longest side, which is the slant height. We've also calculated for the radius. All that we need is the perpendicular height. So to calculate this, we need to refer from the Pythagoras theorem. So we know that from the Pythagoras theorem, so what does the theorem say? The theorem says that in a right angle triangle, the square of the longest side, in this case the hypotenuse, which is also the slant height, should be equal to the squared or the sum of the square of the other two sides. So these are the other two sides. So h squared plus r squared. So we just do our substitution. We know L as 21. So 21 squared is equal to h squared plus r squared. So r, we had 7. So 7 squared. So let's simplify. 21 squared. We have 441. This equal to h squared plus 7 squared, which is 49. So let's group like terms. Numbers on the left, we have 441 minus 49, and this must be equal to h squared. So what is 441 minus 49? 441 minus 49, that is 392. So this must be equal to h squared. We are looking for h, not h squared. So we have to take the square root on both sides. So square root on 392, square root of h squared. Once we do this, we know that the square root and the square will cancel out. So we have h on the right, and then square root of 392, that is 19.7990, 4 decimal places. So we have h as 19.7990. 90. Remember, we were asked to correct our final answer to one decimal place. So one decimal place, we have the perpendicular height as 19.8 centimeters. That is one decimal place. So question 9b, tangent PT touches a circle with center O at a point T. Let's represent this. We have a circle with center O. Now, there is a tangent. Then this tangent touches the circle at a point T. We all know that a tangent is a straight line that touches a circle at only one point. So we have this tangent. Now this tangent touches the circle at point T. So that is the point. We are going to name this point here point T. Then the name of this tangent is line PT. So meaning that we need to name the end point of this line as P. So that is the tangent touching the circle at point T. Now there is a chord. The name of this chord is chord TQ. So let's draw a chord starting from point T to another point Q. So we know that a chord is a straight line that touches the circle at 2 points. So this is the chord. But remember, the name of the chord is chord TQ. So we are going to name this point here Q. So that is our chord. Now this particular chord, that is chord TQ, subtends an angle 3x at the center of the circle. So this chord here subtends an angle 3x at the center. So let's do that. So that is angle 3x at the center by chord TQ. And another angle, that is an angle 120 degrees at a point S. So where is point S located? Point S is located on the circumference below the chord. So the total distance around the circle is the circumference, but we are looking at the circumference below the chord. So from point T to point Q, we can locate S at any point on the circumference, provided it is located below the chord. So let's locate point S. So I'm locating point S here, point S. And then the angle subtended at point S by this same chord called TQ is 120 degrees. So let's represent that. So that is the blue line. The angle subtended by the chord TQ on the circumference. Remember, the measure of this angle here is 120 degrees. So the I part says we have to illustrate the information on the diagram. So that is what we have done. So question 9b. So the I part says we have to illustrate this on a diagram. That is what we have done. Now the II says we have to find the value of x. So how do we find the value of x? Now there is this property of circle theorem which says that the angle subtended at the center is twice the angle at the circumference. So let's subtend an angle at the circumference using chord TQ so that we can apply this particular property. So II, we are to find the value of x. So the same chord TQ, we know that it subtends an angle at the center, which is 3x. So because we want to apply the property which says that the angle subtended at the center is twice the angle at the circumference, we have subtended an angle at the circumference. We have subtended an angle at the circumference. So for referencing sake, let me name this point here as R. So let's find the measure of this particular angle. So all that the property is saying is that, so let's say we have this. Okay, let me redraw this and explain it. We have this circle, and let's say we have a chord. This is the center of the circle O. And then this is the angle at the circumference. So the angle at the center is bigger than the angle at the circumference. Note this. So if the angle at the center is, let's say, 100 degrees, then the angle at the circumference should be half of the center, that is 50. Because when you multiply 50 by 2, that will give you 100. So twice the angle at the circumference is the angle at the center. So now that we have, anytime we have the center and then we want the angle at the circumference, what do? We have to divide the angle at the center by 2. So the angle at the center here is 3x. Because we are looking for angle at the circumference, we have to divide 3x by 2. So that is 3x on 2. So that will be the angle at the circumference. So we have 3 on 2x. So we need to state the reason why the angle at the circumference is 3 on 2x. So let's write down something. So we know that the angle at the center is twice the angle at the circumference. So in terms of referencing, we can say that angle TOQ, that is the angle at the center, angle TOQ is equal to twice the angle at the circumference. So how do we name angle at the circumference? So we can say angle TRQ. TRQ. And the reason is that the angle at the center is twice the angle at the circumference. So we know this particular property. Now, if this is the case, then how do we solve for x? So we also know that opposite angles in a cyclic quadrilateral sum up to 180 degrees. So this is a cyclic quadrilateral, a four-sided figure whose vertices touches the circle. So we have a four-sided figure here, and each of its vertices touches the circumference of the circle. So that makes it a cyclic quadrilateral. And we know that the sum of the opposite angles in a cyclic quadrilateral sum up to 180 degrees. So if that's the case, we can set up our equation. That is 3 on 2x plus 120 must be equal to 180 degrees. The reason is that the opposite angles in a cyclic quadrilateral sum up to 180 degrees. So let's solve for x. So we have 3 on 2x. We are grouping like terms, 180 minus 120. So we have 3 on 2x being equal to 180 minus 120, that is 60. So we are looking for x, so you can multiply each side by the reciprocal of the coefficients. So 2 on 3. So we multiply here by 2 on 3. Then we multiply 60 by 2 on 3. These two will give us 1, so we are left with x. And then 2 on 3 multiplied by 60. We have 40 degrees. Oh, sorry, we have 40. So that is the value of x, 40. Now, II says we are to find the angle between the chord TQ. So there is a chord TQ and the tangent PT. There is a tangent PT. So we are looking at this particular angle. We are looking at this particular angle. That is what we are looking at. So how do we solve for this? Now, to solve for this, this is a tangent. And since O is the center of the circle, it means that line OC, line OQ, and line OT have the same measure because these are the radius of the circle. So if there is a radius of the circle, it means that there is this particular angle. I'm naming the angle here as A. Will also have the same measure as this angle. Remember, triangle OTQ is an isosceles triangle. Triangle OTQ is an isosceles triangle, and we know that in an isosceles triangle, two of its interior angle have the same measure. So with this, we can say that from triangle TOQ, so that is the isosceles triangle. When we sum up the three interior angles, that should be 180 degrees because we want to find the value of A. So we have A plus 3x, and this must be equal to 180 degrees. So A plus A, we have 2A. And then we know the value of x as 40. So this must be equal to 180. So we have 2A plus 3 times 40, 120, and this must be equal to 180. Let me put some space here. So we have 2a being equal to 180 minus 120. So 2a is equal to 60. So when you divide this side by 2, the 2 will cancel out. We have the value of a as 30 degrees. So that is the value of a. But then we are looking at the angle between the chord TQ and the tangent TP. Now remember from the angle properties of a circle that tangent meets the radius of a circle at right angle. So that is one thing we should know. This is the radius, there is a tangent. So they will always meet at right angle. They will always meet at right angle. That is 90 degrees. They will always meet at 90 degrees. So let me represent that. 90 degrees. The radius and the tangent will always meet at 90 degrees. But then one of the angles measures A. One of the angles measures A. So let me represent the remaining angle, the one marked in red as B. The one marked in red as B. So that is what we are looking for. So let me represent that as B. So if that's the case, then it means that A plus B. Wait, let me get a space here. Let me clean this one. You know that A plus B must be equal to 90 degrees because the radius and the tangent will always meet at right angle. So we can say that A plus B is equal to 90 degrees. The reason is that the tangent meets the radius of a circle at 90 degrees. So that is the reason. So if that's the case, then let's do the substitution. What is the value of A? A, we had 30 degrees. So we have 30 plus B. B is what we are looking for. B is what we are looking for. And this must be equal to 90. So we have B is equal to 90 minus 30. So therefore B is equal to 60. So what is the conclusion? So we can conclude that the angle between the chord, so the chord, we are looking at chord TQ, and the tangent. For the tangent, we are looking at line PT, measures 60 degrees.